everyone, and welcome to today's pre-launch status briefing for Orbital's mission to the International Space Station. Orbital Science's Cygnus cargo spacecraft is loaded with about 5,000 pounds of cargo for the space station and the crew. The Antares rocket is poised for liftoff tomorrow at 6:45 p.m. Eastern Time from the Mid-Atlantic Regional Spaceport's Pad 0A here at NASA's Wallops Flight Facility in Virginia. Here to talk about how the preparations for launch have been going are Gerald Esquivel, ISS Cygnus Visiting Vehicle Integration Manager, Frank Culbertson, Executive Vice President for Orbital Sciences, Mike Pinkston, Antares Program Manager for Orbital, and Sarah Daugherty, Test Director at Wallops Flight Facility. For those of you watching on TV, we'll be taking questions from media through a phone bridge. And for those joining us on social media, you can ask questions during today's briefing using the hashtag AskNASA. So we'll go ahead and get started. Gerald, would you like to start us off?
Thank you, Rachel, and good afternoon to everyone. Let me first start by saying, wow, what a great time to be here in Virginia for a launch. We have some great weather, couldn't be better here at Wallops, and we're going to have a beautiful launch tomorrow evening right around dusk. Right now it's an exciting time to be part of the NASA community, and in particular part of the space station program. The space station is becoming a very busy outpost. We have vehicles coming and going on a pretty regular basis now. This past Friday we had our final go, no-go readiness review. It's called an IMMT, where normally in the past we would only address a single visiting vehicle event. We would either have a vehicle coming into the station or a vehicle leaving the station. And all of the station partnership is involved in this meeting, providing the go or no-go for the event. This time, though, we had to address 4 different visiting vehicle events in the near term. Of course, the most important topic of that readiness review was the station readiness and all of the team's readiness to conduct the Orb-3 mission. I'm happy to report that the station partnership did give a go to conduct the mission. So tomorrow we will have the nice launch and then the eventual Cygnus arrival at the space station around the November 2nd timeframe. Another topic that was conducted in that review was related to the Dragon spacecraft. That vehicle was attached to the station at the same berthing port that we have planned for Cygnus. I'm happy to report that the Dragon was released from the space station yesterday morning, and it arrived back on Earth, splashed down around 3:40 p.m. Eastern Time. So that berthing port is now free and ready for Cygnus. And then the other 2 visiting vehicle events that we discussed were 2 Russian Progress vehicles. We have 56P, which is departing the station on Monday, and 57P, which is arriving to the station on Wednesday. So as you can see, there's quite a bit of visiting vehicle traffic readiness discussions that are going on. Once we have the 2 Progress vehicle activities out of the way after Wednesday, the station will be ready to accept Cygnus later in the week, Sunday, November 2nd. And then just to complete the picture of all of the other visiting vehicles that are at the space station, we still have the European ATV-5 vehicle, which is attached, and we have 2 Soyuz vehicles. We have the 39S vehicle and the 40S vehicle. So as you can see, it's quite an exciting time with all of the comings and goings of these visiting vehicles. From a station subsystem and hardware configuration perspective, as I mentioned, the berthing port is now free and ready for Cygnus. The station robotics arm, the SSRMS, is positioned and ready to capture Cygnus when it arrives. Our proximity communication systems that we use to support the Cygnus rendezvous, that has been activated, checked out, and all systems are go there. And the station crew has been readied. They've conducted whatever proficiency training was necessary. Not too much is needed nowadays with as many vehicles that they're having to deal with, but whatever little bit necessary for specific to Cygnus, they've completed. So we're all ready for Cygnus arriving to the station. We have Reed Wiseman and Barry Wilmore will be the two astronauts supporting the capture of Cygnus, with Reed Wiseman doing the actual arm ops for the capture. As Rachel mentioned, we have a little over 5,000 pounds of cargo coming to the station. A couple of cool pieces of cargo that kind of excite me. We have our first high-pressure NORS tank. That stands for the Nitrogen, Oxygen, and Resupply System. That NORS tank, it's a nitrogen tank. It's at about 6,000 psi. So you can imagine quite a few of our NASA safety types get pretty excited when you talk about that kind of high pressure. But that's coming up on Cygnus. We're very thankful, and that's going to resupply some of our high-pressure nitrogen systems in our airlock. We've also got 32 CubeSats and their deployers coming up on Cygnus this mission. Those are always exciting to see them deployed, little 4-inch by 4-inch cubes that go out the GEM airlock. And then another real cool piece of equipment and instrument is called a REBR, R-E-B-R. That's a reentry breakup recorder. That's coming up, and I believe the plan is to attach that to the ATV-5 vehicle, so then when the ATV-5 comes in, the REBR will record all of the accelerations, the stresses the vehicle is undertaking, the rotational items of the vehicle, giving us a better understanding of all the dynamics that occur during reentry. So that's a pretty cool little device there. Now, while most of the vehicle, if not all of it, gets burned up, the REBR is designed to remain intact, and then before it hits the ocean, it does send all of its telemetry to the various sites that are collecting the data so that we understand that reentry. Cygnus, as I mentioned, arriving on November 2nd. The plan is to have Cygnus there for about a month, and then around the December 3rd timeframe, we should have filled up Cygnus with all of our disposal cargo, and we'll be ready to send it off. And I know all of the teams here at Wallops, the Orbital, Mars, NASA teams, are all been working hard, getting ready for this mission, so I'll turn it over to Frank here to give you the status of the Antares and Cygnus.
Thank you very much, Gerald. Appreciate the summary and the optimism. This is the first time I've ever seen a 98% chance of go from the weatherman, so I'd like to talk to that weatherman more often. But on behalf of our CEO, David Thompson, and the entire Orbital team, I want to say what a pleasure it is to be back at Wallops for another one of these big events. We're very proud of the team that we are a part of here between NASA, Wallops, NASA ISS program and headquarters, as well as the Mars team, and all the folks that support this, both our subcontractors and teammates. I especially want to thank the folks that made a quick trip out to Bermuda after the hurricane went through and put that back together and got it up and running in time to support this launch. That was a lot of hard work, and they weren't sure what they were going to find when they got there after a Category 3 went through, but they did a great job of getting it back online, and we appreciate the effort. Given all the traffic that's coming and going, Gerald, I think that we might want to send up some of those red and green wands they use on the deck of an aircraft carrier so Tonto Wiseman can direct everybody in and out of the docking ports. It's getting pretty busy, and we're happy to be part of that busyness and a part of the business as it is. I should announce that this spacecraft, as our past ones have been, is named for a former astronaut and named for a person who's been involved in commercial space flight, either directly or indirectly with Orbital. This Cygnus spacecraft is the SS Deke Slayton, a member of the Apollo 7, who also was the chief astronaut for many years and finally had his chance to fly on the Apollo Soyuz mission. There's a lot more information about Deke on our website and the reasons for naming the spacecraft after him, but he did have an early tie to commercial spaceflight. He was the president of the company that owned the Conestoga rocket that was launched out of Wallops October 23rd, 1995, almost 20 years ago to the date, 19 years ago, and a part of the early commercial effort to commercialize space launch and delivery to orbit. And so we feel we have a good connection with Deke. Dave Thompson and our founders had some connections with him and his partners early in the founding of Orbital and learning what this all meant. So we think it's a good connection, and it's a real honor for us to carry his memory into space one more time. This mission, as Gerald said, will spend some time, we call it loitering, but we'll actually be working from launch until the time we actually rendezvous with the space station on November the 2nd, early in the morning. I do want to remind you all that that is the night or the morning that we change our clocks. So if you're planning to get up, you may have to wait an extra hour if you get up on your old time, because we fall back then. We'll be there on time, right, Frank? Okay. But it is an interesting time to try to adjust what time do you really come to work. And departure, as he said, is planned for December 3rd. We actually will remain on orbit for about 2 weeks following our departure from the space station, conducting tests of the spacecraft to continue to expand our engineering envelope, to learn the spacecraft characteristics, and to get ready for some missions that are coming down the line on later orbital launches, where we will conduct experiments on board the spacecraft following our departure from the station. So it's a good exercise for the team. It's a good way to understand the hardware better, and it'll bode well for future missions. This mission is going to carry over 5,000 pounds of cargo to the crew, a wide variety of items, as you've heard, everything from science to clothes to food, tools, replacement parts, etc. This will bring our total cargo delivered to over 13,000 pounds once we have unloaded all of that and put it on the station in 4 missions. Those 4 missions will have been flown in a little over a year, and we're very proud of the fact that we're continuing to deliver on a regular basis and especially deliver cargo to the station. We're going to bring cargo away from the station also, and so far we've brought almost 10,000 pounds of some people call it trash. We call it disposable cargo off the station that is returned to Earth, burned up during re-entry, hopefully, and especially with some of that stuff. And we'll bring another probably 2,500 kilograms, or about 5,000 pounds, back on this mission, bringing our total to almost 15,000. So it's a real pleasure and a real honor for us actually to be a part of continuing to support the space station, to continuing to ensure that they can keep 6 people on board, keep them supplied, keep them clothed, keep them busy with the research that's going on. And we hope to continue to build on that, do it more and more frequently, and do it for many years to come. We're very proud of the fact that we are a part of human spaceflight in this country, proud of the fact that we are continuing this outpost in low Earth orbit, which really is just a stepping stone to what we're going to do next, which is to go beyond low Earth orbit, go out to the moon, continue to explore that, and eventually go to Mars and to asteroids, and continue to explore our solar system. And Orbital and other companies are an essential part of NASA being able to do that, as well as our international partners. And we think it's a great team effort. We think it's important for the future of humanity. It's important for understanding our Earth as well as our solar system. And we think it's important for the future of our next generations to come. And we hope it's an inspiration for the next generations to come, because, as you probably know, we fly experiments for all ages. And we have experiments flying for nonprofits, for universities, for various organizations that go up as small payloads on board the commercial cargo delivery vehicles, and who continue to keep our kids that are in school now inspired, keep them involved, and hopefully keep them taking math courses so they can get through engineering in college. But we think that's an important part of our job, is to keep the next generation interested in this, so that we don't stop doing this. Because if we stop doing this, if we stop flying humans into space, and if the U.S. stops being the leader on that, the next generation is going to be really upset with us, because they're going to have to start over. And they really do want to go to the moon and Mars. They told me. So now I'm going to turn it over to a real rocket scientist, our program manager for the Antares program, Mike Pinkston.
Thanks, Frank. On behalf of the entire Antares team, we're all excited to be back here for prepping at Wallops for our 3rd mission of 2014. I think I've got a short video to talk you through on some of the pre-launch preps that have been going on in our horizontal integration facility and on out at the pad. This is a photo of the fairing and then the Cygnus during the final cargo loading operation. Here we are up on the TEL getting ready for fairing mate. That's our team closing out the fairing. And then this is a shot of the fairing being maneuvered over the front end of the vehicle to encapsulate the upper stack and the Cygnus payload. For those paying close attention, you'll notice that there's an extra cylinder on the end of the fairing this time that accommodates the extra 2.5 meters or so of length that comes with our new Castor 30 XL second stage. This is the rollout process. We actually got out of the HIF the afternoon of, or Friday afternoon around 5 o'clock, got it to the pad and started the erection process. You can see it making its way to vertical late Friday night. I think we actually got there and upright sometime shortly after midnight. It's quite a long process. We drive really, really slow, and we erect really, really slow. But you know, once it's up there, it's a really beautiful sight. So, you know, as far as where we are right now, the team's been working hard at the pad, Orbital, NASA, Wallops, and the Mars team. We've actually, maybe the first time yet, are going to finish a little bit ahead of schedule. We got the combined systems test completed last night. Final pad preps are going on and should be wrapping up right about now. So, you know, just due to a combination of factors, we actually ended up being able to roll out a few hours early Friday, and the team did a great job getting everything complete, and you know, may even be able to get off and watch a little football Sunday afternoon. So that's good for our guys. I would like to also add a special thanks to the Wallops team for just an incredible job getting the Bermuda site back up. You know, they exceeded anybody's expectations in terms of our earliest potential launch capability. But they pulled off a miracle and have us ready to go on Monday, and I think when you see the weather report, you'll be as glad as I am that they made it. So with that, over to Sarah.
Thanks, Mike. Like Frank and everyone here has mentioned, the NASA Wallops Range is excited to be here to support this third mission, commercial resupply mission to the space station. And what we're responsible for is tracking and data relay, as well as ensuring the safe flight of the rocket. A little bit earlier, our facility director, Bill Robel, gave the authority to proceed for the mission, and that's our final milestone into carrying out the countdown tomorrow and proceeding with the rest of the launch operation. From a data and communications perspective, we have range instrumentation, including radars and telemetry antennas, as well as command here at Wallops, as well as downrange in Bermuda. And you've heard everyone talk about Bermuda already, so we had a crew go out there about 2 weeks ago to secure and stow the site there for us in preparation for Hurricane Gonzalo. After that passed through, we got the guys back out there as quickly as we could, which was just short, about 3 days later. And then we checked out our systems. We unsecured everything, set it all back up, did some functional testing, hooked up the data lines and power, and was actually able to complete a host of end-to-end data flows and test procedures on very short order, things that would normally take us 7 to 10 days. Really, we got done in about 3 or 4 day time frame. So definitely kudos to the team out there. They gave quite the Herculean effort after such a huge storm went through, and we were lucky to not sustain any damage at all that would have prevented us from doing this on such a short time frame. So with that, I'll also go into the weather report that was also mentioned here earlier. The launch weather officer has a forecast for very clear skies, very light winds out of the southwest, and temperatures in the low 60s, and all of that gives us a probability of 98% for go launch conditions, and that's probably just due to the fact that the weatherman is never 100% right, so we had to knock it back from there. And the last chart I have to show here is just a visibility map due to the weather forecast and the fact that the launch is going to be one of our first nighttime launches of the Antares rocket here. You'll be able to see the rocket pretty much up and down the entire eastern seaboard there from about Connecticut to South Carolina. We'll have a great view of Antares lighting up the night sky. And then just as it fades off, if you keep your eye up there, the ISS will actually pass over about 5 minutes after launch around 6:50 p.m. So that's kind of a cool double show there for everyone. So with that, I'll turn it back over to Rachel.
Okay, thanks. All right, we'll take some questions from folks in the audience here. If you wouldn't mind stating your name, affiliation, and to whom you're addressing your question, that would be a big help. And as a reminder to those watching on TV, you can send us your questions on social media using the hashtag #AskNASA. Okay, Ken, looked like you had a question.
Hi, Ken Kramer, Universe Today and America Space. For Gerald and Frank or Mike, I'm curious about this nitrogen tank with 6,000 psi. Can you talk about how you're going to maneuver that in, what the astronauts have to do to get that into the station, and what they will do with it when they do get it inside? Thank you.
Sure. The nitrogen tank is actually coming up in a what looks like a very similar to all of our other regular cargo bags. So it's got some extra support structure to keep it stable, but in general, there's no special crew aids or anything to handle the tank. It's been designed for the various fault tolerance necessary to prevent any kind of leakage or burst. And we have a assembly kit already that was brought up on the Orb-2 mission, which the tank will be inserted into to transfer the nitrogen over into the airlock high pressure tanks. So from a crew perspective, they're going to be handling it just like they would any other cargo bags until they get it to the airlock, and then it just goes right into that assembly kit that's already been installed previously.
From Orbital's perspective, we've spent several years now satisfying the NASA safety process in a number of areas. This one got our attention, and so we put them through the same process, and had them prove to us that it really was well designed. Its storage and handling is all as it should be and safe, and we're convinced that it's fine. Our team has already handled it, loaded it onto the Cygnus, as you know, and it's out at the pad. And so we feel very comfortable with it as a system. It's not overly huge, as Gerald said. It's manageable, but it is the highest pressure vessel we've ever carried inside the Cygnus.
How big is it?
Oh, I'd say it's about 3 feet in length and maybe 18 inches in diameter. Some people say a bread basket.
That's a really big bread basket.
Well, I like bread, so.
Go ahead, Stephen.
Hi, Stephen Clark with Spaceflight Now. A couple of questions. First, maybe for Mike, can you talk a little bit about the Castor 30 XL, its differences from the upper stages you've flown before, and what sort of improvements of performance you get out of that new upper stage? And also maybe for Frank, can pitch in on this as well. Do you need this new upper stage along with the enhanced Cygnus that you'll debut on Orb-4 to meet your contractual requirements for the 20,000 kilograms, or is this sort of icing on the cake above and beyond the 20,000? Thanks.
Go ahead, Mike.
I'll take the first part of that. The Castor 30 XL is an extended length version of the Castor family of motors that we've flown on all of the first 4 missions. In some specific terms, it's about double the total impulse compared to the Castor 30B that we flew on Orb-1 and Orb-2. A little higher thrust, burns about 45 seconds longer than the Castor 30B. So, overall, just a much higher performance. Second stage, as I mentioned in the, talking through the video, it's also, quite a bit longer. It's, between that and the ultimate extension of the Cygnus PCM to support the full enhanced cargo capability that we're bringing online. It's about a 2.5 meter, so what's that, maybe 8 to 10 feet in length that's added to the total length of the Antares vehicle. And it roughly, just the 30XL itself, roughly gives us another 800 to 900 kilograms of payload to orbit capability. So overall, I think it's going to be a great enhancement to our cargo service, and yeah, we need it.
And as far as increasing the capability of the system, when we won the contract, we already had plans for a performance enhancement program partway through the system to ensure that we could, in fact, carry our contracted amount of 20 tons to the ISS. We started with lower delivery numbers to begin with, and have gradually increased it as we work off our contingencies and our margins. But we needed this part of it, the enhanced cargo carrying module, which is a meter longer, as well as the increased performance on the second stage to really meet our goals. And we are, in fact, doing that. And as Mike said, 800 or 900 kilograms of additional cargo over what we've done the first few missions will be our capability going forward. And we needed the extra volume in order to carry that. And as we go through this program and in future, we hope, programs with NASA, we will continue to increase that performance as we go.
Okay, Robert.
Hi, Robert Perlman with CollectSpace.com. For Gerald and Frank, sort of building off of that and the mention of all the visiting vehicles that are coming back and forth. When Cygnus births, it'll be the 14th anniversary of Expedition 1 and 14 years of continuous crewed operations. Can you talk a little bit towards the evolution of logistics support on orbit and what it says about our current capabilities that so much payload, so much cargo comes back and forth between the space station?
Go ahead, boss.
Wow. You make me feel old by talking all the way back to Expedition 1. I've been part of the space station program since the beginning, so I'm feeling really old now. But like you said, you know, we had a very robust capability when we had the shuttle around, and when we retired the shuttle, it was, you know, we had to rely on our international partners to provide the resupply to the station. And when we had the concept, the strategy to involve the commercial partners, commercial providers in starting to bring our cargo to station, that was quite an exciting time. Not only was it going to be doing something different at NASA, but we were going to be returning some of that resupply capability to the United States. When you include the 2 demonstration missions, this will be our 9th commercial flight to the station. And as they have demonstrated, they are very capable of bringing all of the cargo needs that the station has. The HTV and the ATV vehicles provide some other unique capabilities, but getting the day in and day out needs of the station now via our commercial providers has been key. And we see that continuing on with our future contracts, as well as when we eventually go with the crew transport. And I'll let Frank answer any other part.
Well, first of all, Gerald, when you said you feel old, I started working this stuff almost 20 years before that, so what are you trying to say? It is gratifying to see it going so well and to see the ability of American industry as well as our international partners to support this program, even without the shuttle. The shuttle was a key part of building the station. If it had been able to continue, it would have been a key part of continuing to supply it and probably expand it. But without the shuttle, we need all of these vehicles coming and going in order to support the research on board and to keep the crew healthy and well-sustained. It is a logistics problem as well as an operational problem for the program to solve, but that's part of what we do in the space program as we continue to increase capabilities. And if we're going to want to keep people in space and go beyond the space station, which means even more people going into space, we've got to keep this going, and we've got to figure out how to do it as efficiently as possible. I think it's a testament to both the program as well as the suppliers that we can interweave all of these capabilities, coordinate between the various entities and international partners, and still keep it flowing fairly smoothly and keep the research going. So I think that you'll see even more complicated scenarios in the future as we go forward and try to go beyond where we are now.
Okay, let's take some questions that we're getting on social media. Go ahead, Jason.
Indeed. This first question comes from Twitter user Launch Complex, who's asking, I'm wondering, will the recent solar flares present any issues for Orb-3 launch like they did for the Orb-1 launch in January?
Not that we've seen. But we always watch space weather.
All right. This question comes from Twitter user James, who asks, with the launch scheduled about 37 minutes after sunset, will the vehicle reach sunlight during ascent?
I predict that it will, but I'm not sure.
That's my prediction also, Frank, but I don't have any hard evidence to
Okay.
support it.
This comes from experience of
Yeah.
seeing launches right at sunset.
Indeed. Twitter user Jim asks, what are the benefits of launching from Virginia versus Florida versus California?
Well, the benefits are that we have a launch pad here that is compatible with our vehicle. Number one. And secondly, we feel it's important for the United States to have as many capable launch vehicles or launch processing and launching facilities as the industry can support. Wallops is a very capable site. It's been developed to deal with larger vehicles now that Antares is launching out of there and out of here, and they could support even others that if others wanted to come here. But it also helps deconflict some of the traffic that also goes on at Kennedy Space Center and Cape Canaveral. Just like the station has traffic issues, there are launch traffic issues going out of Florida. So having the two sites, Virginia and Florida, we think is very good for the country and good for the ISS.
Excellent. Last question here comes from Scott on Twitter, who asks, what kind of trash does the ISS generate?
Normal trash.
No. Was it the kind or the amount?
The kind.
Yeah.
Can we take that?
Sure.
Since I generated some of that many, many years ago, Gerald. A lot of it is packing for your food that you consume. You've got to do something with the food trash. A lot of it is clothing that's been worn, and since we don't have a laundry facility up there, you throw it away and then you return it in whatever vehicle is leaving next. Wet towels from bathing. The remnants of old experiments that are no longer being used and have produced all their data, they will sometimes send that hardware down, not to be recovered but to be disposed of. There is certainly human waste that has to leave the station in very tight containers that actually works very well, and so we return that in all the vehicles that are disposed of in the atmosphere. And then anything else the crew just doesn't need anymore. When you think about it, the station is a closed environment, so anything that goes up there has to have an end-of-life plan for how does it get off the station. Otherwise, you just keep filling up that container, and there's eventually not going to be room for the crew. So every kilogram that goes to the station, an equal kilogram has to come off, or a cubic meter has to come off. So you got to think of it in those terms. There's only so much room. It's like my daughter's bedroom, you know. I mean, only so much can go in there before something's got to come out.
Okay, let's see. Do we have any more questions here in the room? Let's go right here in the middle.
Hi, my name is Rebecca Moore. I'm one of the social media contacts for NASA. Before I came, I took some questions from some of my followers that I have. This question really goes to, you spoke earlier about how the missions like this are important for continuing to be able, for the next generation to be able to go to the moon and go to Mars. And a lot of the questions I was getting are, when's the next big deal things? When's the next, when are we going to set up a permanent colony? When are we putting a man on Mars? And so how are missions like this contributing to those, long-term goals that Orbital Science and NASA and other commercial space flight places have?
Let me just say one thing, then I'm going to turn it over to the government official here who has all those answers. But this is the next big thing. Flying on the space station is a big deal, and I wish people understood that better, because it's not easy to get 6 people up there and get them back safely, and it's not easy to keep them supplied. It's not easy to develop the payloads and the research that goes on up there. People put their entire careers into these projects that end up on the station, and some of them last for years and years. And people really do build careers around them. But it is the future for low Earth orbit for people who want to be astronauts or who want to be involved in space on the human spaceflight side. And so it is a big deal, and I wish people understood how difficult it still is to get people and things into orbit and to get them home safely. and to live up there. They have to do spacewalks. They've got to work a full schedule, and it's like being on an outpost anywhere else where you're living in hazardous conditions and you can't always go outside when you want to get away. So it is a big deal. And then the future of NASA, I think Gerald's going to cover.
Well, as Frank is saying, spaceflight is a very difficult business, and having the space station in low Earth orbit there, providing a microgravity environment for both science as well as technology advancement is very key for our future travels to the Moon, the Mars, and further out. We have a lot of things geared going on at the station right now to support understanding those longer-term missions. Next year, we have our first expedition where we have crew members staying on orbit for a full year. Normally they are staying up there no longer than 6 months, and so we're trying to make sure we understand all of the physiological changes that might occur to the human body with a lengthier time on orbit. And then when you talk about some of the systems, spacecraft systems that are going to be necessary for these long missions, those items have to be very reliable and have multiple strings of redundancy, because you are going to eventually have a failure from time to time. And demonstrating those technologies, the reliability aspect of those devices, those subsystems on space station, is providing invaluable information to our engineers, to our scientists in developing those systems that are going to take us beyond low Earth orbit. So, and then later this year, I understand we are having a big Orion mission, so that'll be our first real good test of that vehicle that's intended to take us beyond low Earth orbit. So it's pretty exciting.
If I could add one other thing, there is one other big deal here that's being demonstrated by this particular launch tomorrow, and that's the fact that NASA and industry are changing their approach to how we do exploration and how we maintain a presence in space. The Commercial Resupply Services contract between Orbital and NASA and SpaceX and NASA is a good example of that, but it's not the only one. NASA and other government agencies have always relied on contractors to implement and develop and execute new programs and build hardware, but this is a more commercial approach that was begun back in the actually 80s and 90s on a small scale by Deke and his company, by Dave Thompson and his company, and now by Elon and others who are moving the boundaries of commercial activity in space further and further out. And I think that partnership is going to enable us to go beyond low Earth orbit and allow industry to be a different type of partner with NASA and other agencies in developing our access to space, both for humans and for robots, as we continue to explore the solar system. So the business frontier is moving along with the space frontier.
Okay, we have time for one or two more questions if there are any more here. Don't be shy if you have a question. Let's go here in the front.
Hi, Robert Perlman with CollectSpace.com again. With Halloween right around the corner, is it safe to say are there any treats on board for the crew?
I'm not at liberty to say. Might be a trick. And they might be watching.
Got one more here?
Questions from second graders. Second graders at Oakville Elementary would like to know what's the best thing about being an engineer or scientist working on these projects?
Well, you get to work on spaceflight. That's the most exciting part. We're leaving the boundaries of Earth. You're working on some of the newest technologies. You're always pushing the envelope. It's things that engineers strive for. So working for NASA, working in the aerospace industry is just a wonderful place to work as an engineer. So that's what I would tell any student right now.
I'd just say watch a rocket launch, and you'll have a hard time finding something cooler than that. And between that and what we're doing to really expand the frontier, it's just exciting. And I'm not sure there's a better job for an engineer or a scientist.
Mike?
Mike beat me to it, but I was going to say tomorrow. That's the most exciting thing, is actually launching a rocket. And when you're a part of that and experience that, it motivates you to want to learn and have hands-on experience with everything involved in that.
All of those things are true, and the only thing I'd add is that you get to work with people like these and people like out there, some of the smartest people in the world, some of the people who are most excited about their jobs and who feel the greatest sense of satisfaction when it goes well and the most frustration when it doesn't, but who never give up. And it's an amazing industry to be a part of, and I highly recommend it, whether you are going to be a political scientist or a business major or an engineer or a scientist or a doctor. There's nothing better than spaceflight in terms of having a future that is probably somewhat unknown, but always exciting. And if I could maybe add a little bit more to the Halloween question. Robert, when I was on station during Expedition 3, we did have a crew come knock on our door on Halloween, October 31st. They had launched from Baikonur, and they were there trick-or-treating. They were dressed as cosmonauts, and they brought us treats. So, and we had a few for them. So it was a nice Halloween.
Okay, let's take one more in the back from social media, and then we'll go ahead and conclude.
This question comes from Twitter user Kieran, who asks, wondering how long the launch window is for Orb-3 and why?
The Orb-3 launch window is 10 minutes in length, and it's really driven by performance and targeting requirements that get us in the right orbit at the right time, that allows Cygnus to do what they need to do to rendezvous with the space station. It is actually a little bit longer than the last couple. I think we were working with 5-minute windows previously, but because of this particular configuration with the bigger second stage and not a fully enhanced Cygnus, we're able to open the window up a little bit and give us a little more time if we need it.
And as Sarah mentioned, if you watch the night sky after liftoff, a few minutes later, you'll see the International Space Station go over. 5 minutes, right, Bill? And that tells you what's happening is we are launching so that we end up slightly ahead of the station, and then it'll start catching up, and then we will phase until we end up beneath the station, and 2 or 3 days later, depending on when our rendezvous actually occurs, when we'll be in the same orbit with it. So it's all part of orbital mechanics, and it's partly magic, partly math. So.
Okay, well, I want to thank everyone for joining us today. If you'd like to watch tomorrow evening's launch, our NASA TV coverage starts at 5:45 p.m. Eastern Time for the 6:45 p.m. launch. And you can find out more about Orbital's mission at www.nasa.gov/orbital.